Okay, I think we're ready to go. So welcome everybody to our webinar today. My name is Dr. Catherine Ibbotson. I'm a Director at Strategic Advisory at WSP. I'm also the Chair of Driving Net Zero Carbon Community of Practice. Thank you for joining us today on the webinar, which will be covering low carbon materials in transport infrastructure. But before we begin, I would like to cover a few housekeeping rules. So today's webinar is being recorded. The presentations and recording will be made available. All attendees are in listen-only mode. Raise your hand or send a chat message if you have any problems with your connection or audio or any other issues, and one of the CIRIA team will help you. There are plenty of time for questions at the end of the webinar, but please do use the chat box for any questions, put it in the Q&A, and please state if you want to direct your question to a particular speaker. We'll monitor the questions as they come in and click on the thumbs up if you like other attendees' questions so we can help identify the most popular questions that come up. Please share resources in the chat. We're keen to hear about your webinar experience and would be grateful if you could complete the short poll at the end of this webinar. Also, if you'd like to receive a CPD for this event, you'll also need to complete this poll. Please share your views and experiences on LinkedIn. I encourage you to do that. So please connect it in terms of build offsite, at CIRIA, hashtag net zero carbon, hashtag construction, and hashtag transport. We aim to finish this webinar at 12. Okay, a little bit more about build offsite. So set up in 2004, it's the voice of the industry. Build offsite was sought to promote, support, and increase the adoption of offsite and pre-manufactured solutions for the built environment. And this is very much to be a trusted independent voice of the construction industry. Our build offsite members, we have about 60. You can see those on the screen. Also, a little bit more about CIRIA. So for those who aren't fully aware, we recently celebrated the 60th anniversary as a not-for-profit member-based organisation. Our core strength in terms of CIRIA has always been about improving performance through collaboration in the built environment and construction sectors. We do this by delivering independent guidance, such as the Sustainable Urban Drainage Manual, the ROC Manual, International Levy Handbook, Asbestos and Biodiversity Net Gain. CIRIA organises around 30 events per year, mostly online at present, but they range from topical conferences, annual debates and lectures to webinars such as this. Our CIRIA members, as you can see on the screen, we're a small but growing organisation, about 85 members, and as you can see on the slide, there's quite an increasing number. But we'd like to thank our Driving Net Zero Carbon Community of Practice member and supporter for their support over the years in this area, and that is WSP. A bit more in terms of our net zero carbon offsite champions. Now, build offsite champions are modern methods of construction and aims to embed sustainability and deliver net zero across the sector. This project will provide robust evidence of MMC carbon benefits, and CIRIA and Build Offsite will assess and quantify the net zero outcomes of offsite construction. While our 2020 CIRIA and Build Offsite report found reliable data on waste, the sector has since advanced. Clients now set carbon targets, standards have evolved, and offsite solutions are delivering measurable savings. The project will showcase 8 to 10 leading case studies, quantifying embodied and operational carbon, waste reduction and energy efficiency, and is currently seeking technical and financial support. The link will be shared post-event for those interested in terms of the technical side, but also for financial contribution. Now, over to our webinar, what brings us together today? So this webinar series has been developed in collaboration with Build Offsite and CIRIA's Driving Net Zero Carbon Community of Practice to discover how the increased adoption of low carbon materials could support greener practices in the construction sector. And also, ultimately, to help the UK achieve its net zero carbon emissions by 2050. The webinar will explore how specific timber, steel, low carbon concrete could reduce the embedded carbon in our roads, rail, airfields and ports, including examples of MMC delivering practical net zero carbon outcomes. Now, our speakers today include Steve Eltikin, who's Director of Environment Sustainability at National Highways, James Craven, Road Senior Engineer at WSP, Joe Lewington, Chief Environment and Sustainability Officer at Network Rail, Graham Jones, Manager Director at CPro Systems, and Musa Chung, Technology and Innovation Principal Engineer at Laing O'Rourke. So just a reminder to please type your questions for the speakers using the questions box. We will pick them up as the discussion progresses. Also remember to click the thumbs up if you like other attendees' questions. This will help us identify the most popular ones. So let's begin with our first presentation from Steve Eltikin, Director of Environment and Sustainability at National Highways, who will be presenting on the Carbon Reduction Challenge. What are the challenges that need to be overcome? Over to you, Steve.
Good morning, everyone. Steve Elderkin, Director of Environmental Sustainability at National Highways. We're working to transform the environmental performance of the road sector, the highway sector. That means thinking about how we can be positive for nature, the land that our road network occupies and how it sits within the broader landscape. It means tackling local environmental pollution, but in particular, it means transitioning to net zero highways. So, 5 years ago, almost, we published our net zero plan in July 2021, and that has 3 headline targets. The first is that we will get to net zero for our own corporate emissions by 2030, which feels quite close now. And second, that we'll get to net zero for our construction and maintenance emissions by 2040, and then that we would get to net zero for our road user emissions by 2050. There's a lot going on across the company and across the wider sector, and we very much see ourselves as an important part of this, setting the direction as the client and the infrastructure owner. But this is about changing a system that consists of designers, contractors, material producers, as well as how we operate and maintain the network. We've been making good progress across all 3 targets. So by the end of last financial year, we were down by 70% in terms of our corporate emissions. That's the offices and estates, our depots, our own 1,300 vehicles that occupy the network, that operate and maintain the network. We think that will be getting close to 75% by the end of this year. So we are making good strides towards that 2030 target. Things we're doing, we've transitioned almost all of our light fleet now to plug-in or hybrid electric vehicles. They will all be moving to fully electric vehicles by that 2030 target date. We've been changing an awful lot of light bulbs. That's actually quite a big project, and we'll be getting towards 70% of our lights being low energy light bulbs by 2027. We're making use of sustainable travel and travel hierarchies and hybrid working, shrinking the size of our office estate. And we've got more than 100 depots and outstations where we've got solar panels for stooning the roofs, all being installed as we speak, lots of energy efficiency measures, and so on. In construction and maintenance, we became the first major roads authority in the world to get a certified carbon management system under the Managing Carbon and Infrastructure Standard PAS 2080. We've had that for over 3 years now, and every year we get audited, and it's a journey of continuous improvement. And I'll talk a bit more about PAS 2080 later in the presentation. We've been trialing and testing materials. We've started to put carbon requirements into our contracts. And again, I'll talk a little bit more about that as we go through the presentation. Road user emissions are very large, so something like 7 or 8% of UK greenhouse gas emissions are emitted by the users of our roads. So this matters. The pace of reduction is lower, and one of the challenges here is we need the help of broader policy and innovation around vehicles, but we are starting to see a decline as the take-up of electric vehicles increases. So our net zero targets have been validated and approved by the Science Based Targets Initiative. I've gone on too many. So some of the challenges for construction and maintenance emissions in particular, 2/3 roughly of our construction and maintenance emissions are embedded in the materials that we use, and that's very much dominated by the steel, the concrete and the asphalt that's used in the construction and maintenance of our roads. So we need to work in partnership with those specifying the materials, those manufacturing the materials. We need our standards to allow innovative lower carbon materials and additives to be used on our schemes, and so there's a responsibility for us as the holder of the design manual for roads and bridges, a set of standards that are used by more than 100 countries around the world, to be agile and to be adapting those to the innovations that are happening. The performance of the sector will be decided by decisions that are taken throughout the system. And so there's a big piece around levelling up people's understanding and awareness of carbon, the opportunities that exist for reducing carbon, and getting thought of carbon into decision making at every level. And we're obviously reliant on supportive policy, regulation and funding from government, who hold some really important levers in this area. PAS 2080 is a global standard for the management of carbon and infrastructure. I'm sure Joe will talk about it too for Network Rail, but all of the DFT family, the Department for Transport family, are adopting this as a standard. It's got some really important principles in it. So first best is to avoid unnecessary construction, then it's switching, and then it's improving efficiency and durability. A lot of these opportunities are greatest at the earliest stage of a scheme. So right at the beginning, carbon, environmental sustainability, thinking about how to improve the environmental performance of project needs to be there. If you leave consideration of carbon until the last stage of the project, the opportunities to design out will have gone. We also know that within the construction sector, there is a relatively high amount of rework. And so obviously if you pour some concrete, rip it up and pour it again, then that's a very high carbon way of constructing. So quality, right first time, really matters. And then durability is also important. So if you can extend the life of the pavement, the asphalt, then that's a really sound way of both delivering cost savings as well as carbon savings. It will also, of course, require some innovation around the materials that people are using. PAS 2080 isn't just for us, and we see it as a key enabler of us being able to have confidence in the decisions that are being taken throughout the system, that the data that is being reported between our suppliers and ourselves is accurate is that all of our supply chain are either accredited to PAS 2080, or if they are a smaller supplier, that they've aligned to the principles. We set out in our 2021 net zero plan that we would require all of our supply chain to get PAS 2080 accreditation. And happy to say that now 86% are on the way there, and we're obviously engaging with the 14% who are not as yet making progress. It is now going to be part of our tenders and our contracting, where you will be disadvantaged as a supplier if you do not have evidence of either having or working towards getting PAS 2080 in your company. We've recently updated our standards to make them more outcome based, to permit the use of more concrete additives that are lower carbon substitutes for higher carbon clinker. We are also changing things like the length of time that you're allowed for the concrete to reach strength. Again, all of this makes it more flexible, more open to the specification of lower carbon materials and mixes. And we are open to feedback and the use of our departure system to gather information about other ways that our supply chain want to adapt the materials they're using and to reduce carbon. And so we are compressing the amount of time that it takes to take materials through to being used on our sites at scale. Transparency, sharing, learning. We set up a carbon hub. More than 1,000 of our suppliers have used this and accessed this. We've made available all of our carbon management system documentation. We've curated a set of resources around low carbon construction. All of the recording of our own webinars and so on are put up there, and it's all about this idea that actually, just as for safety, where it's too important that we are safe, it's too important that we're reducing carbon to try and make any commercial advantage out of this. If we've got something that works, we want to share it, we want to see it adopted across the sector. And so we've urging our suppliers to take a similar approach to that they have done with safety, to share what they've learned. And we have a low carbon opportunities register, which has a whole set of opportunities which have been already implemented on some of our projects, and so they raise awareness that these opportunities are available, and we require, as our projects are taken through their design and development, that they consider the applicability of these opportunities to their schemes. Innovation requires work from the kind of idea stage in the lab. We then need to trial in the real world, and then start deploying, update our standards and get deployed at scale. Proud of the work we've been doing with Nottingham University, with a number of members of our supply chain around asphalt. And here we've really compressed the amount of time it takes. So we have been running the lab trials to manage our understanding of the technical risk with innovative materials for asphalt, so whether that's graphene or biobinders or higher recycled content or different additives, testing those in the lab, getting them out onto our network in demonstration trials within 6 months, and then updated in our standards, and starting that process very much more quickly. So we think that will cut 5 or more years off the time it takes to go from idea to available at scale across the industry. And we've been using the Low Carbon Demonstrator Fund to fund projects across our network, and that's mostly been around asphalt and resurfacing, but we've also been funding um, plant machinery, concrete, and other ways that we've been reducing on our projects. And this gives us learning in the real world about any of the challenges that these changes present. Focus areas, 2/3 of our emissions are from materials, so we need to focus there. We must take a whole life approach, so it's no good saving a bit of carbon in construction if it doesn't last, and we have to replace it sooner. And we are looking at things like echelon paving and different ways of delivering surfacing to reduce the number of joints and improve durability. And we are particularly on sort of trailblazing sites like the Lower Thames Crossing, our biggest project, testing the use of electric and hydrogen plant at scale. An example of one of the low carbon demonstrator funds is a resurfacing project on the A47. Here they used cold asphalt for the binder course, high levels of recycling content. All the plant and machinery was electric rather than diesel. And in total, just on that one project, it saved 600 tons of carbon dioxide. This is just one example. So we had another project on the A64, which different supplier ran, but that achieved more than a 70% reduction on that project too. So we are starting to demonstrate really deep reductions in terms of surfacing emissions. So thank you. Hopefully that gives a bit of an overview of the activity that's happening in National Highways. Happy to pass back to you, Kat.
Right, that's great, Steve. I think it's a real demonstration in terms of the impact a client can have and all of the different layers of approaches that are needed to make an impact. So thank you for your presentation today. So let's begin with our next presentation by James Craven, Road Senior Engineer at WSP, who will be setting the scene. Why, as designers, we have a large impact on reducing carbon emissions. Over to you, James.
Yep, morning everyone. So as mentioned, I'm James Craven, Senior Engineer in the Roads team, WSP. I also sit as the Roads Community of Practice Decarbonisation Lead, and leading on quite nicely from Stephen's presentation. I've also been leading on our carbon management across National Highways SDF framework as well. So I've sort of direct hands-on experience of working through what Stephen's been discussing. So just to start off with, I wanted to run through kind of high level as designers, how much of an influence we actually have on the carbon emissions that were within our project. So as was alluded to earlier with the sort of hierarchy and ability to influence whole life carbon as you go through a project life cycle, it greatly reduces the more mature that a project actually gets. So we really want to be getting involved as early as possible to have the biggest influence that we can. Within conceptual design, we look into kind of what are the different design options that we have. So as we're going through design level assessments, we want to be looking into how we can change key aspects of design to be constructing less, so that sort of a void of construction activities, and using that to help influence that decision making when the option is selected. We then go through into prelim design, where we are focusing more on sort of general layout, functionality, and aesthetics. And within here, we can then start looking further into those low carbon opportunities in terms of materials and processes that are used, and start to have these discussions with the contractors and suppliers to try and bottom out some effective measures that we can implement onto the project. And then going further into detailed design, that's really where we get into the key detail of it. We want to be doing our finalized baseline and looking at exactly what the carbon emissions are that we are proposing to save from implementing these low carbon opportunities, and then feeding this through the value chain to make sure that they are practical suggestions and that they are fed through to the contractor, and then they are actually built as suggested. In the bottom right, you can see a good table that's from PAS 2080. It details out the sort of project stages that we look into for carbon assessment. So the A1 to A5 is very much the sort of project and construction stages. So quite well established embodied emissions. People fairly well can understand that. But then going through into the use stage where I think there's less understanding of sort of the operations and maintenance side of carbon emissions, and trying to make sure that we're incorporating that into our carbon thinking and carbon reduction, and then also into end of life. So the decommissioning, recycling of materials as well, and how can we ensure that throughout our design processes, we are making sure we're considering all of these life cycle stages. Um, so as designers, we will set out a baseline at the start of the project. So we look at what the carbon emissions are within the project before we've looked at any measures to reduce them. This is really important because it lets us hotspot the carbon emissions, see where the highest amount of emissions are sitting within the project, so we know exactly the key items that need to be tackled. Following on from this, we go into a quantification stage of looking into suggesting new sort of low carbon opportunities that we can implement onto the project, having these discussions with the contractors and suppliers and the client, and ensuring that they are practicable and we can implement them on the project, and then looking into actually what the effects of this are. It's all well and good saying we're going to use a low carbon material, but until we've actually proved the savings that we can get on the project, it's difficult to justify the improvements that we get from it. And then out the back of that, we really want to be reporting this through the whole value chain, making sure everyone's aware of what's gone into the processes, how we are managing the carbon, and make sure that really we have a continuous improvement loop out the back of it, where if good work's being done on a project, we want to be showing that off to other projects, making it clear that these innovations can be taken further and can be used for more widespread carbon reduction changes. Um, as was discussed earlier, the carbon hierarchy is one of the key sort of guidance of how to manage carbon and try and reduce it as much as possible. So the avoid action is key because the biggest influence we can have on reducing carbon is by building less. If we're building less, there's less carbon going into it. And it's about trying to change thinking away from a lot of the time people think, oh, we need to use this new innovative technique that's a new material. But quite often, the biggest influence we can have is if we just take a step back and think about our design and think, can we justify changing it? Can we look into how we can change parameters of our design scope to make sure that we are actually building less? And then from that, we can feed into the switching of materials and looking into those sort of low carbon opportunities, and then going through into the proven efficiencies and design processes. Um, I think there's a bigger picture in terms of whole life carbon that often not considered. So this is by no means an exhaustive list, but some of the key considerations that we do think about when we're looking into whole life carbon are on the right. So program implications. Are you suggesting something that's going to extend the program is not going to be feasible within the scope? We need to always make sure that what we are suggesting is practicable, but there might also be low carbon opportunities that are actually reducing programs. So then on site, there's less fuel use and there's less of the operations and maintenance side of emissions. Local constraints. We need to make sure that we're always fitting any of our innovations within the environment that the project scope is. We can't just be across the board suggesting the same innovations because it's not always practical for those locations. Health and safety is a key one. I think people often think carbon is its own standalone thing, but health and safety aspects often come into it. It might be from, for example, if you're looking into an active travel scheme to reduce transport emissions, that because you're making a dedicated cycle lane, that improves the health and safety of those cyclists. They're not actually then cycling on a live road network. Or it might be that you're looking into using a VRS that's got a longer design life, which means that it doesn't need to be maintained as often. So you don't have to have operatives out on site that are maintaining it on a live carriageway. So it's definitely something that needs to be considered, in my opinion, more in terms of the carbon. And the innovation maturity goes into sort of, we do at times want kind of the blue skies thinking, but as I've mentioned, we do want things that are practical. But then we also want to be striving to find projects that we can try and use new solutions on that haven't been used before and use those as trial projects so we can see the effects of them on a small scale and then take that learning to a more sort of framework or group projects approach. And that's where we can get the large scale change. And then as always, cost is always an element that's been brought up in terms of carbon management, and I think there's a bad rap of an idea that it's always going to cost more. I don't think that's the case. A lot of the time, if you can say extend design life, then the operation and maintenance side can be lower, and often there can be a higher upfront cost. But if you look in the full life cycle of a project and then down to the decommissioning stage of things, that the actual whole life cost can be lower. And until we actually model that and look into considering carbon with cost and program and all of these different elements, we'll never know. And we need to be considering them all together. I've just got a couple more examples of some examples of low carbon opportunities that we have implemented on road projects, and a lot of them we're trying to push to make more that sort of business as usual activity. So the warm mix asphalt and cold mix asphalt is quite a well established thing, but trying to make sure that we are developing this on our projects and providing it where possible is looking into things such as biobinders, which are using uh, biological elements in the binders, which obviously, if we have large stretches of pavement schemes, this can have a big impact. A lot of these, say, for example, road markings on an individual project, when you look at the hotspots, the road markings for a junction improvement might be a very small percentage of the total emissions for that project. But if you look across a framework of projects, things such as road markings and lighting, that really does add up. And if you can make a small percentage improvement on a project that can then be spread across a wide scale framework, then you can make massive improvements. And it's all about those incremental changes that we can bring in. I think one that's always flagged up to me is the geotech elements of earthwork. So a lot of the time, the geotech team will come in at a later stage when designs have started to be developed already, and it limits their ability to minimize the amount of earthworks that are required, which obviously has a massive amount of carbon emissions from sourcing the materials and hauling them in and constructing it. So can we be building in these considerations earlier into our design processes of making sure that all the disciplines involved are considering carbon from step one, and that we're all discussing together how we can sort of work together to minimize them and make sure that we're incorporating different people's elements into our projects. VRS, again, a lot of the projects, low carbon steel and concrete is quite a well established low carbon solution. It's about still ensuring that we are suggesting it on our projects and pushing it forward. But then there's other things such as SUD solutions for, instead of using traditional filter drain materials for VRS drainage, there's other solutions that can be used which are lower maintenance, lower cost, and have carbon savings as well. So it's building in that full picture into our design. Just a quick study looking at M5 Junction 23 Dumble roundabout, where it was a dedicated roundabout cut through realignment works, where we worked with Balfour Beatty and Somerset Council to create a carbon strategy around the project. So as part of this, we baselined our carbon emissions within the baseline design and identified those hotspots. We then conducted innovation labs with the client and contractor, where we then produced a long list of opportunities that we thought potentially could be implemented on the project. So it was very much a get everything down on the board so we can then shortlist that. And that was our next step of taking the key items within there, which we thought would have the biggest impact, shortlisting those, and then feeding those through into KPIs for the project, where we then assessed the carbon savings and then validated this through research and case studies. So as part of this, we looked into 10 key KPIs, which were including lower temperature pavement materials, recycled curb units, longer life road markings, lower carbon concrete mixes, and reducing the amount of paved areas. So you can see in there, this kind of feeds in through all of the avoid, switch, and improve processes into one. And as a result of this, we had a 33% reduction in carbon, which is equivalent to 638 tons of CO2. So you can really see how just switching thinking and considering that hierarchy can really lead to carbon reduction straight into the project from working with the clients and contractors. And then as my final slide, I just wanted a bit of sort of a food for thought to get people thinking about how we can change how we're doing things at the moment. So, from a strategic approach, as I've mentioned throughout the presentation, a lot of the time people are pigeonholed onto individual projects and they look, okay, what can we do on this project? And then they finish that and then they go on to the next project. But if we did look at a safe framework of projects, how can we hotspot the framework as a whole and look into where the biggest opportunities we have for wide scale carbon reduction to then be implemented across a range of projects rather than just on an individual project basis? Um, it's all about identifying where these trends sit and where wider opportunities we can draw from and build into the projects. Another key thing it's been developed this year is as 3090, which is looking into climate adaptation and modeling that. And could we potentially be looking into more preventative design by doing some climate modeling, looking into where our key areas are that are, say, prone to flooding and tackling that before the flood events happen? Into process and measurement, it's all about ensuring that the correct things are measured. We want to be making sure that we are as transparent as possible with our measurements and that is then fed through into the value chain to make sure that everyone's very clear and measuring in the exact same ways. Off the back of that is target setting. We need to be understanding what is enough, what is good, and what is great, so we know on our projects if we are doing enough and if we are pushing in towards the net zero targets that we have. And then is into the cost and program implications that I mentioned earlier, is getting a better understanding of how that all feeds through into the system and the whole life approach of projects. Into people and culture, we need to make sure that we've got the correct roles and responsibilities across that full life cycle. And we really need to be pushing to change thinking within the industry that carbon management isn't just an add-on, it's something that we should be doing more wide scale. And it's obviously very important that we do it. And we, especially within the sort of design side of things, we need to be developing people that have both the design expertise and have carbon expertise so that we can start this from stage one within our projects. And as I've talked about, that innovation and collaboration side of things with contractors and suppliers and designers and the clients, we need to make sure that we're talking more and working together to feed through new innovations and sharing that knowledge process that we have across all of our projects. And then really it's about investing in that process, investing in the people, investing in finding low carbon opportunities, and then pushing those. So thanks for listening, everyone. That's me. I will pass back to you, Kat.
That's great, James. I think that point about integrating carbon and understanding into existing disciplines is essential. So it's not seen as an add-on, but a core part of delivery. So great point there. So thank you. Just a reminder, please type your questions for the speakers using the questions box. And remember to do a thumbs up on the questions that you want to try and prioritise. So let's begin with our final presentation from, sorry, not our final one, from Joe Lewington, Chief Environmental Sustainability Officer at Network Rail. We'll be presenting on the process, how we implement carbon management into projects, and you can see on specifying low carbon materials. So over to you, Joe. You're on mute, Joe.
Thank you. Apologies, schoolgirl error there. I couldn't find the unmute button and now I'm whizzing through my... Great. Okay, here we go. Sorry. Well, first of all, thanks very much for having me. Hopefully everybody can hear me now. And you can see the slides. So I am the Chief Environment and Sustainability Officer at Network Rail. I sit in the Technical Authority department. We've been on a journey, it's fair to say, in the railway over the last 5 years. So we published our very first strategy, our environmental sustainability strategy, back in September 2020. Fast forward 5.5 years. Last year, we updated that to align with our new kind of strapline of a simpler, better, greener railway. And we developed our greener railway strategy, which is far more comprehensive. It looks more at sustainability sustainability in the round rather than just the environmental aspects, which I think is really important and demonstrates a level of maturity of the journey that we've been on. But for today, I thought we could focus in on just some examples of smart materials that we're adopting for a greener railway in support of our greener railway strategy. So a lot of this comes down to three kind of key components, if you like. We use a lot of sleepers, a lot of rail and a lot of ballast on the railway. Now, they may not look glamorous, but that's where some of our biggest carbon wins sit. So even small improvements in how these are made, transported, reused, they can add up to quite large carbon reductions. And importantly, these changes also support our supply chain resilience and that kind of long-term cost reduction focus. So if I start with, and hopefully this is going to behave, if I start with sleepers, we buy around 400,000 sleepers every year, and 90% of those are concrete. So we have different types of sleepers, and actually I'm not really going to touch on another type of sleeper that we use, but it is still also quite important, is the composite sleepers that have been developed recently as well. But for this one, we're focusing on concrete. So until recently, the cement that was in them was one of the biggest kind of carbon hotspots in our materials footprint. But by working really closely with our suppliers through our supply chain operations team in route services, and in particular with Cemex, we've switched from traditional cement to lower carbon blends, and we've improved the manufacturing process. So the change in cement chemistry cuts out a big chunk of the most carbon intensive part of our cement production. So that the result of that is that we've been able to reduce by about 45% the carbon in every sleeper. That equates to around 12 million kilograms of carbon CO2 each year. And we are now exploring more kind of innovative sleeper shapes that use less raw material but perform even better. So we've worked with universities like Southampton to help us explore how we can reduce the carbon content. And obviously performance requirements remain a challenge for us. We obviously need to make sure that this isn't just about cost and carbon reduction. This is actually, ultimately the railway needs to maintain performance and safety. But this is a great example, I think, of the innovation that is happening inside an existing product. So, it's something that your average passenger wouldn't even notice, but it is really massively transforming the carbon focus on a key material for us. So if I go on to the next big ticket item, as I call them, of what we use in the railway, and that is rail, and specifically steel. So we purchase about 80,000 tonnes of rail every year. Through our new rail contract, we've been able to mandate that a portion of this must be low carbon rail produced using an electric arc furnace. And that uses recycled scrap metal and renewable electricity. So essentially this gives us 62% lower carbon compared to traditional steelmaking. Around 20% of our total rail volume now comes from this new low carbon source. And I know it comes from Europe, so that is still a challenge, but transporting it by rail means that it is still fairly low emission. It is sometimes, it is a more expensive product at this point in time. So it costs around £70 per tonne more, but the carbon benefit is significant. And ultimately what we're wanting to transition to is a kind of a more resilient supply chain in this space going forward. That's rail. And then the final kind of item that I wanted to cover off was ballast. And this one I feel is really quite exciting. So through testing with Southampton University, we discovered that we could actually safely mix used and virgin new ballast together to create a 50/50 blended product that meets all of the requirements that we need it to. The benefits from that are pretty amazing. So just over 500,000 tons of virgin stone saved each year, 1 million kilograms of CO2 saved annually. This was as a result of quite rigorous product acceptance. So as you would imagine, so that was achieved in 2024. And it's being rolled out across the estate now. So with a new tender coming online in 2027, it means that this will become available more widely across the whole of the UK, making it the norm rather than the exception, which it has been years gone by. So just summing up, I think there's just some examples of the key materials that we use. We use thousands of different types of materials, and we know that our biggest challenge for us is scope 3. So it's what sits within our supply chain primarily. We can't do this in isolation as a client. We need to work with our supply chain on tackling the circularity and the carbon aspects of these materials. But it's really, really exciting to see, just using these 3 big ticket items, what we're already doing. I think there'll be further innovation around sleeper design to cut carbon from materials even more. As I said earlier, there's a UK-wide ballast tender underway, which hopefully will bring further investment into regional processing and blending facilities. And then, depending on obviously about how the UK steel sector evolves, there's an opportunity most definitely in our supply of rail there. So it's all about kind of closing the loop so that more materials that we're using can flow back into manufacturing rather than go off to landfill or disposal. And each of these kind of helps us reduce carbon, improve resilience, and reduce the kind of whole life cost. So, when we talk about decarbonising transport and the infrastructure, people often think, oh, it's these big, shiny, big ticket innovations. But actually, what we've just demonstrated here is actually, we're quietly in the background, just innovating the fundamentals of how we're kind of tackling this collectively, both as a client and and with our supply chain in partnership. I think that is my final slide, Kat, and I will hand back over to you.
That's great. Thank you very much, Jo. We've got some questions coming through as well, so that's really, really encouraging to see. So please do remember to do a thumbs up on the questions that you want to get asked at the end. Just so people are aware, Steve will not be on the panel at the end, but we will collate the questions and make sure that responses are sent out to all attendees. So let's now move on to our next presentation. Graham Jones, Managing Director at CProbe, who will be presenting on specifying low carbon materials, key opportunities for specifying low carbon materials across asset types. Over to you, Graham.
Hello, everybody. I'm very pleased to be here. The subject matter for me is more on existing structures and how we're looking after them rather than necessarily new, and how we save on those materials. So about sustainability and resilient preservation of structures in the built environment. And I'm going to run through from identification of issues through to that whole life management issue that we've been talking about earlier. And specifically, I'm a corrosion engineer. I'm a fellow of the Institute of Corrosion. I'm a CP specialist. And the biggest issue for infrastructure is probably the one that's closest to my heart, therefore. 70% of infrastructure damage is down to corrosion. Of course, other things can happen to structures, but corrosion is a very, very big issue. And it's a changing landscape. We have a lot of structures now already built. I think the tagline on that is 95% of infrastructure already exists. We're topping it up with the occasional new structure, but we have large stock of aging infrastructure that needs to be maintained and looked after. And this particular paper that I quite liked demonstrated that 3 to 6-fold increase in structural repairs are likely to be needed as we approach to 2060. So a lot of lost material and a lot of new material being used. And of course, we've got to look after what we've already got. So we're designing new. And as the speakers have already said, we want to make those sustainable infrastructures and follow past 2080 where we can, and use logical materials to achieve that. So as we use that new material, we are investing a lot of embodied carbon into that structure as we build it. And that build is only as successful as the resilience of the structure is, and it manages to achieve its service life. And that in many ways is dictated by that environmental exposure and time to disrepair before we have to start really looking after it. There are steps we can take earlier, of course. It's probably subject of another day, but building in from new is also possible. So once we get to that end of resilience or the end of service life stage and resilience is diminished, we basically have two choices. We can either demolish, and having demolished, try to recycle some of that material, add it to new material and build again. But some of that will be disposed and wasted. So we have lost a lot of embodied carbon. What challenges us in our business on a day-to-day basis is how can we take that built structure and repair and repurpose and make it last longer? Now that inevitably will also take some new material, but retains an awful lot of the structure that's already in place, with a key factor being as early as we can get in, the better, because we're allowing the disrepair to be minimized. So using less material to repair and carry on. But of course, that new material we can take a look at as well, and we can reduce the carbon of that new material. Just because the original build was, say, with Portland concrete, doesn't mean to say that other materials can't come and meet the challenge to reduce that carbon footprint. But we start off with identification of the issues. I'm not going to dwell on this too much. There are some very sophisticated techniques out there now that give us all the information we need on the condition of a structure. The one I'll highlight and maybe spend a couple of seconds on is the one on the top left, where the on the left-hand side is actually a bridge joint. It's actually on a bridge for New Jersey Department of Transportation. And our job on this one was to try to assess the impact of that leaking joint on the bridge deck itself. And as you can probably see from that half-cell potential map, most of the deck is still fine, but there's a creeping risk issue coming from the joint. So having identified that issue, we can develop a strategy. We know the condition, we know the intervention is needed, but there are other factors to take into account. Not all of a structure needs intervention all at the same time. In some cases, if you take the example of the bridge deck again, some of it is actually still in good condition. So intervention would not necessarily be required straight away. And certainly a leap into demolition would be pretty silly. So levels of intervention can be dictated by the condition assessment data that's achieved, both in terms of the environmental impact, chemical attack, chlorides, carbonation, what its current risk is, and bear in mind a half-cell potential map is not telling you that corrosion has propagated, it's telling you what the risk is in thermodynamic terms, and gives you time to meet those challenges and to develop a design strategy to intervene. So having decided to intervene, we also have fairly mature standards. The N1504-9 is a very mature standard now for mitigation design choices, covering on -9, 11 different principles. They're primarily trying to stop the ingress of moisture, the ingress of accelerants like chloride and carbonation. Once in the structure, of course, we then want to be able to control it. So we have choices on control. We could do surface treatments. We can do cathodic protection. You can do galvanic systems. You can do chloride extraction. All sorts of techniques and mitigation choices out there to try to alleviate the problem. And it's also a hold point. What materials are we going to choose to achieve the principles of the service life extension when we come to remediate that structure? And there are systems coming on board now that allow us to decarbonize some of the materials being chosen. In our case, these come with our low-cent products, which have independently verified Type 3 APDs verified by BRE Global, which inform the engineer during the design process of just what those materials are achieving in terms of carbon reduction and environmental impact. Of course, doing the LCAs on these is more than just CO2e, but and can inform on other features such as contamination of marine and the likes. So we have our EPDs for the repair materials themselves, but I would highlight that also we've done the calculations for the EPD for the whole of the cathodic protection systems. So not just taking on board the anode system, but taking on board that there are monitoring tools in there, there are cables, there are cable management, there is power control and monitoring electronics, and all these are part of that carbon footprint and need to be assessed, and this EPD does do that. I think the challenge for EPDs comes in, and we had this challenge while we were trying to debate the data with BRE, particularly in the cathodic protection. Cathodic protection is in place to extend the service life, and with control and with the right materials, could potentially control that the issues indefinitely. So to get to the circularity question on landfill recycling or removal of the structure at the end starts to get a little bit more tricky, because there comes a point where you say, well, service life can carry on. Whereas the corrosion's under control, structure itself is intact, it's still got structural integrity. At what stage does it ever need to be demolished? And I think EPDs need to develop that knowledge base in order to properly assess that Scope 3 circularity. So in our case, we achieve these low carbon credentials by repurposing waste materials, by not using heat, just repurposing waste powders, blended into geopolymer formulations that allow us to repair, build, and also in terms of a very specialist formulation, allow us to use that binder to create a mortar that could conduct and be in itself a mortar anode. And that's a bit of a game changer. So those features of geopolymers being low carbon also are comparable with normal mortars and concretes in terms of compressive strength and improved flexural strengths. Very little shrinkage, very highly thermally stable, cures at negative temperatures and can withstand fires to 1200 degrees for 5 hours. Very highly resistant to sulfate. We have had this independently assessed by the BRE under an Innovate UK programme. And acid resistance out in the Netherlands and the water industry, where the geopolymers have withstood pH 1 sulfuric acid vapor for 3 months without change. And we are very proud to be top of the class there. But the unique anode properties allow us to take control of corrosion, and very high current densities are possible before acid is actually generated. So there's lots of technical features and reasons to embrace different cements to create that low carbon, sustainable, resilient capability. And retrofitting is normal. You can target it by drilling it into complex steel areas like the half cell, the half joint you see there. You can spray it. We're very pleased to see that spray gone in without very little rebound and mess, which is good news. Or you can cut it into decks and control corrosion based on the steel configurations deep within the structure. So infrastructure preservation is really just done normal contractually, but just with a different material. And on a case study, and I apologise for it not being a transportation one, unless you can count bikes that run over the top of these podium decks. But this is a very large podium project in New York City, the Bronx, that we're doing at the moment for threat protection. We have 40,000 square meters of 3 different podium decks. They unfortunately have to remove 18,500 square meters of that to a depth of 600 millimeters to then be replaced. And that is just simply because they didn't catch it in time and allowed it to develop into a major problem. So, of course, there is a loss of CO2e there, and we calculate that based on iStruct's little cube there that takes into account all features to make a cubic meter of concrete. So a loss of 3.9 kilotons of CO2e due to that slow decision making. But then retrofitting in press concrete protection to the other 21,500 square meters will save the other 5.5 kilotons. New material added in there is negligible addition because of the low carbon nature of the materials, and that's good news for the project, of course. But having completed thorough protection of 40,000 square meters, the whole of the decks, then there's no further loss of CO2e, preservation of 10.3 kilotons of CO2e. That it's all data and remotely controlled to assure performance to international standards into the future. Our dashboard kind of looks like this. This one is for one of our clients, the West Lothian Council, where we manage 7 of their thorough protection systems on bridges. And we have this dashboard to reassure them that everything's intact and meeting standard. And if not, then we highlight it in the amber and red, and we can then tackle the control remotely and then refresh. And all this leads to a very new but good certification process that Lloyd's Register Quality Assurance have developed. It takes all these features together, from low carbon as well as its resilience, as well as its quality of installation and its normalcy of placement, and tiers it in a bronze, silver, and gold standard in order to achieve that net zero digitization as well as structural integrity and resilience with their new accreditation scheme. And this has been rolled out across not just buildings, but also for transportation. And I would encourage you all to contact LRQA and find out more. So our closing statement would be to think differently. We can decarbonize for whole life by repurposing industrial waste to look after our structures to secure that embodied carbon that's been invested initially, but with sustainability, with built-in future-proofing and control. And I'll hand you back to Kat.
Thanks very much, Graham. Much appreciated. So let's go to our final presentation, which is Musa Chung, Technology and Innovation Principal Engineer at Laing O'Rourke, who will be presenting case studies, examples where this process has been used. Over to you, Musa.
All right. Hello, everyone. Hope you can hear me okay.
Yeah, I can hear you.
It's been a really good session so far. I've really enjoyed hearing what everybody else is getting up to, and just thinking back to sort of the earlier days in my career. It's really nice to see how the conversation has matured. And how much energy is going into all of this. I'm Musa Chunga. I work for Laing O'Rourke in our technology and innovation space with a focus on product development for offsite solutions. And I'm going to talk you through a little bit of what we're doing as a case study with some of our partners around actually forming routes to deploying some of the low carbon materials at scale through our offsite technology. So my current space of work is really in infrastructure, mainly transport and grid infrastructure. But today I'll be talking about what we're doing in the bridge space. Now at Laing O'Rourke, we have a product-led approach to how we construct bridges, and that involves us manufacturing some of the components. So we do that particularly around the substructures, but also integrating components from the rest of the supply chain to provide a complete solution. One of the key elements of the way we build bridges is what we call a modular precast abutment shell. It's a cellular element that is a non-participating but stays in place for the whole life of the bridge, concrete piece that stacks very quickly, has integrated temporary works, and really unlocks a new method of construction. And we've been deploying bridges like this with significant repeating benefits, which is something that I find really encouraging. Wherever we go, whatever requirements that we shape the offsite solutions into, we get to see similar outcomes. That's significant step change in on-site productivity, where we've gone from traditional methods to what you can kind of see on the screen with clean sites, small specialized teams putting in structures with 60 to 80% less effort required or less time on site for those elements. We're seeing rapid acceleration in programs. We're seeing the benefits from that come from reduced prelims. That often drives a cost savings, especially in really congested sites, really disruptive areas of construction, which we often see for bridges. And we're seeing improvements in waste. The predictable method of construction brings a lot of continuous improvement and learning. And the average values for waste on our schemes around concreting, for example, is really coming down by 90% for some of these elements and the substructures that we're deploying these elements on. So really good outcomes. That picture there was an abutment, one of the abutments we did on the HS2 Birmingham interchange scheme. This is now almost 10 years ago, and we've deployed about 20 structures with this methodology. Some of the more recent ones have been on very significant infrastructure in the UK, at the M25 junction 10, where the A3 crosses the M25, where we've done 8 structures down there. And just as an example of how those benefits keep coming, we had a request here from the two big airports that consider this as a critical route to them, Gatwick and Heathrow, to actually move a closure in the program because they were worried that the bridge construction would be too disruptive. So we were able, because of the methodology and because of the way we were able to deliver, actually bring that closure earlier in the program, which is rarely something we hear about in construction, and deliver it on time to plan with the outcomes that I've just mentioned, the productivity benefits, the construction benefits, the reduced impact on traffic management, durations and schemes. And we're doing more and more of this. Our biggest scheme at the moment is now on the M42, where HS2 crosses that big section of motorway. And we're rapidly deploying our solutions. They're shaving off a whole year off the program. Now, if we just look at the A1 to A5 stages, what I say with our approach, we've done a detailed case study on that HS2 bridge that I showed. We did a like-for-like, fully designed traditional equivalent to the modular method that we used. We measured it up. We took it to the level that we would execute in construction and developed an A1 to A5 measure of the embodied carbon. Now, we shaved about 4% off the embodied carbon in those stages using the modular approach. A lot of that actually driven by construction efficiencies. Material is probably about like for like with a couple of things going down and a couple of things going up. So we're at least as good as kind of traditional methods, but we're unlocking all these other benefits. So I took that as a challenge to say, okay, we found a methodology that gives us some really strong repeating benefits, but how can we do more? So how can we get better with carbon? And one of the ways we can do that is to actually look at the materials that we're using in these systems. So we've been separate to bridges, just more generically, trying to look at opportunities to bring in alternative solutions and materials into our manufacturing processes, embedding those into products and creating pathways for them with high technical and manufacturing readiness, and at the right commercial positions where we believe these things will actually be cost competitive. So we've been looking at, one example is a geopolymer solution developed by Wagner's called Earth-Friendly Concrete, and how we can bring that into our manufacturing products. In parallel, we've also been looking at basalt fiber reinforced polymer bars. One of the suppliers we've been working with is Bastec in that space, but there are others in the market. And these materials have interesting opportunities. The geopolymer concrete provides an alternative binder solution that significantly reduces the carbon content of the concrete itself. The basalt reinforcement provides an alternative option to steel reinforcement, which is actually in tensile capacity significantly stronger than steel. It's also quite a lot lighter than steel, but it does have some behavioral nuances that impact your design. But done well, that can also bring in significant savings. in carbon. An example of that is in particular elements, we're seeing almost a 90% reduction in the mass of reinforcement by bringing these alternatives, which also has knock-on effects in terms of the type of work that is required to fabricate these solutions. Also a lot easier for the people working and fabricating these elements. Excuse me. So we've been looking at this in terms of embedding these products into our technology. So we've been embedding these into our production systems and taking particular elements into testing and trialing. So quite a bit of investment in terms of actually finding the right products and the right avenues to deploy these products in, and demonstrating that they actually work. So we have the engineering theory, but do we have the physical evidence that demonstrates that that theory is actually repeatable and can be deployed accurately? So we've been doing a little bit of work with these materials in individual, kind of a progressive adoption of them, and also a combination of them in the products to test our engineering theory and have sort of controlled deployment mapped out. We've been doing structural testing at the BRE, and starting to look at how we create the pathways into project deployment with these elements with the right levels of confidence. But we found out that we could only get so far on our own. So we began to then congregate with a partner in Ramble on the design side and with National Highways on client side to actually bring together an aligned effort in this area to actually define the pathways into the market. And we found that we did share ambition. I think this is an important thing to recognize, and a day like today is also quite good. The shared ambition to decarbonize exists, which is good. We can form a common goal towards that. We found that with these bridge elements that we produce, there's enough of a pipeline to actually target innovation towards and have a repeatable system, a scalable system with a variety of risk profiles, and I'll come back to that a little bit more. And we can build on the existing MMC benefits. So we saw this opportunity with the offsite approach to actually come up with an integration pathway that was controlled but had enough of a pipeline to go on a journey with. We all recognize that scaling is hard, and the supply chain does need support here. And I think it's important for the client to be involved in these conversations, and contractors like ourselves to be involved in these conversations, and designers as well, because we all interact with the supply chain in various forms and ways, and we need to pull in the right support and enable the right signals to the supply chain that there will be a pipeline. There are mechanisms that we can create to help integrate new materials, and what we're doing here is an example of creating those mechanisms and pathways. We also all recognize that we rarely have time to innovate on projects. Projects don't have enough program capacity for the innovation journeys that we need to go on to get the best of what we can. Projects have limited financial capacity to actually invest in innovation pathways, and the risk associated with it is also significant. If you're doing it first time on a project, you can sometimes be asking for too much risk. There's a lot of pressure that comes with it, and sometimes innovation doesn't work. Sometimes we need to fail things fast rather than fail them on projects where it actually costs significant. The impacts can be a significant cost. We all want to be committed to innovation, and the phrase we like to use that we can start with better as we get to the best. We can progressively grow how we deploy and deliver better solutions. And we all have an appreciation, I think, understanding the client's landscape, the asset operators, the asset owners, understanding the design challenges, understanding the delivery and the execution challenges. We all have an appreciation that we have to balance the risk of change with the need to change. So coming back to our shared ambition to decarbonize, we have to get to that, but we have to balance how we do that with as little risk as possible. So what we're doing, following on from the progress we had made with kind of exploring materials, establishing a manufacturing and technical readiness, we then applied for funding to National Highways, and this is just going back to, I think, the first presentation we had today. It's very helpful to have clients that are investing and supporting research and innovation into new areas. That funding is really about creating a phased approach to deliver value. So we're not trying to do everything at once. We're creating a phased approach to integrate new materials incrementally at the right risk profiles and create pathways for suppliers and designers to be able to adopt these things early without having to try and do everything in a project context. So we're developing generic content. In the national highways space, this is developing the generic departure content that will allow specifiers and designers to be able to understand what would be required of them, create a very clear process to adopt particular types of novel materials for particular use cases. So we've created a kind of hierarchy of risk, and we're creating a clearer set of requirements alongside the risks. So for example, if you're in temporary works, you might not need to satisfy the fully fledged requirements for all your materials. If you're in a permanent but non-participating element, you might have a certain additional level of criteria. If you're in a fatigue sensitive element, you will have a much more onerous set of criteria to demonstrate. But we're creating these kind of thresholds of risk that go alongside equivalent materials specification needs to create clarity and certainty that if we go down these paths, we are likely to be able to get to a consistent position of adoption of low carbon materials into particular schemes. So we've tailored the use cases, and we're also leveraging emerging standards like the BSI Flex 350, but looking at those and trying to fill in the gap between the emerging standards and the actual client-specific requirements. Again, we're trying to bring in clarity. So what we're doing is we're developing in the first phase of research, a basalt fiber reinforced polymer bar structure of departures. This is a generic design departure. How do we approach design using this material? And then a material specification departure is how do I specify this material for that right risk profile? So phase one will be how do we create the generic it'll actually be for FRP materials in general, but with basalt as an example of how that works. And we'll start with that non-participating elements with the bridge shells. And phase one will then allow us to start feeding that into trial projects. And I think our hope and aspiration is that we'll be able to get that into the Lower Thames Crossing framework, where we have a significant number of bridge structures. Second phase will then focus more heavily into the alternative concrete solutions, so things outside the realm of the BS 8500 series of specifications and standards, and will again form a generic design departure and a generic material specification to national highway standards that allow users and specifiers to be able to identify the right criteria and evidence that they will need to provide for a material to be evaluated and assured for use in the highways context. And again, we'll start that with the lower risk elements, and then progressively as we go forward, move into a higher and higher risk categories and develop testing and evidence basis for how these materials will be scaled. And we're expecting that projects will come along as we go further. And we'll also, in the second phase, start to look at what do we need to do for the combination of novel materials. So it's easier to handle one introduction at a time, but we'll also be developing guidance and generic content around, okay, how do we bring two different novel entities together and make sure that the combination of these materials doesn't introduce unknowns that we aren't able to manage and control. As all that goes along, we need to be drip feeding into projects to get early value in. So again, we won't figure out everything in one go, but we'll get better before we get to best. And this mechanism will really help, we hope, to facilitate sending the right signals to the supply chain. And that's coming back to the signals. Our ambition is we want to give process clarity. How do we get new materials in at the right risk profile with a balance of the need to decarbonize, but also the need to kind of control and manage future use and operation and maintenance of these assets. As we give requirements clarity, that will send the right signals to supply chain. So if you imagine a new innovator coming in, trying to develop a new material, if they have clarity of the pathway that they need to get that material deployed in, that can help with that early development and testing and evidence base that needs to be generated to provide that approach. The requirements clarity also takes pressure off project innovation opportunities, where the projects can then be starting from a position that is 80% of what would have been typically done to 100% on a project, because the content exists, and all we have to do is then shape to the specific entities and elements that the project will need. So it becomes a much less onerous task for projects to follow a process to innovate and adopt novel materials. We'll also be providing evidence and examples through the work we're doing, which will be good kind of case studies and reference points for the industry to say, okay, it is possible. We can do this. We can deliver change in the right way, and we can work together collaboratively to do so. And importantly, we will then start to see the benefits and the impacts of doing things differently, and that will help to unlock even more carbon savings from what we're currently able to do at a faster pace. Okay, that is my session. Thank you for the opportunity to speak. I look forward to engaging on questions.
That's great. Thank you very much, Masa. Really interesting presentation there. I'm sure we're going to touch on some of those points a bit further. So now for the Q&A session. So I'll invite all the speakers to turn their microphones and webcams on. I would also like to welcome Ken Davey, Industry Advisor at Build Offsite, to join the panel. We have received quite some interesting questions, some directed at some individuals, so we'll try and weave those in. If you've not yet submitted your questions, now is the time to do so. Remember to click on the thumbs up, and we can identify the most popular questions as we go through. Okay, so just one of the questions that have come up in the chat, and it's come up in a couple of different guises, is around innovation. And when we talk about innovation, where the risk lies, how quickly innovation can land in terms of a project from start to finish, and also the overall impact of a new material coming in. So is it looked at from end of life? Is it looked at from a broader impact, not just materials themselves? And you've all slightly touched on this in a different way, but I'd just like to go around the panel in terms of to hear your input in terms of when you're going about identifying new innovative materials, what is the process that you go through? What are the things that you need to draw out? Who would like to go first on that?
I'll go first if you want. Yeah, obviously as an SME, and we regard ourselves obviously as innovators, the task at hand is really getting that proving data to give everybody sort of confidence that the material is actually going to perform the way it expects to, which leads to a time from an innovation point of view before you can properly commercialize. So there's always a challenge to any innovator on timescales. I think the frustration might come in where we might feel we've got that proving data, and get it to the wider market is also in itself a step that's a challenge. You've almost got to treat each individual engineer within each individual engineering practice as a customer, and try to get everybody convinced gradually. So to actually get it widely known as quickly as possible is always a challenge for an innovator. Because then obviously on the engineer's desk is then got to go through the specifying process, etc., assuming that they've got themselves to the point where they are convinced that the material is worthy of implementation. You're on mute, Kat.
Would anybody else like to come in and add a bit more to that from your Joe?
Yeah, thank you, Kat. Thanks, Graham. I think it's really important that we also look at our whole supply chain. So actually some of the really innovative solutions actually do come, as Graham said, through SMEs. And I think sometimes there's challenges for them to kind of find their way through, what is quite a huge supply chain in our case at Network Rail. Obviously, fundamentally, running a railway, safety and performance is the kind of key priority. and I would add sustainability and sustainable solutions, of course. So that's always at the forefront. But I think what we've got to do, and it feels like we're on a journey here, we're not quite where we need to be, but is finding ways for us to engage more directly with all of our supply chain, not just tier ones, but SMEs as well, to find those innovative solutions. And some of them are, like I think I mentioned earlier, things like the composite sleepers. We've worked on a project called the Hedgehog Sleeper, which is fully closed loop, made out of recycled materials, really quite innovative. We want more of those kinds of products because I think in every single product we use, there are opportunities, and we don't necessarily have the answers as clients, and that's why we rely upon our supply chain to help us with that journey.
Yeah, and I think you've all touched on in different ways. It's not always about new material that comes in. It's about incremental gains with existing approaches and materials, which actually can have a significant impact.
Can I
James,
add to that a little bit, Kat, as well? Sorry.
So go on, Marcia.
I was going to say that one thing we are coming to now is also identifying the risk profile of what we're trying to do, and then providing an appropriate specification requirement for materials based on that. So one example is with basalt fiber reinforcement bars, there's very little data on how they perform in fatigue. So if I have a non-fatigue application, I don't have to get the supplier to provide me everything that the world says is needed for fatigue performance to be able to use it in a non-fatigue application. That's the kind of thing as well we're trying to do. So it gives us a progressive route to deploying materials while we also build up a bigger and bigger bank of information. So it's about kind of meeting the suppliers with what's available, but also managing the risk of how we deploy.
And just coming back to you, Joe, because there is a shared risk across clients, isn't there? Clients don't always work in isolation. Yes, you may have different sectors, but actually all the challenges are very similar across the board. And can I ask you to touch on that a bit more in terms of cross-client working?
Yeah, certainly. So, one great example of that is the infrastructure client group, where we know that a lot of the challenges that we're facing are not unique. They are pretty much similar across our client groups, and therefore working together to send clear signals to supply chain as to what we're requiring as clients, looking at technology, research and development to help support on some of those, again, the bigger ticket items, is what we need to do, because fundamentally there's no point us going off into our silos and trying to find these solutions individually. We can get it done faster and more effectively if we come together. So that's a journey that I think we've been on over the last few years. It's great to see us working collaboratively on some of our shared challenges, and I think that will just increase as we move forward.
Yeah. And I think that also allows for collective piloting of different innovation as well, because we don't want to see low carbon solutions and just being for one sector when they can be used across the board, but actually they may react differently in different sectors or different use, and being able to have a fuller understanding of that end-to-end use, where the risks lie, how it should be used in practice, I think is important to really shift industry forward.
Yeah, just to add on to that and what Joe was saying as well, I think that sort of knowledge sharing is really key, especially early in the processes for us as designers, is having that conversation with ECI and suppliers to identify not only things that we're suggesting that we have seen as our hotspots and what we want to implement, but things that they're also trying to implement. There might be some new items that they potentially want to trial on a project, and if we can support them in identifying where we can do that, that's how we can build that bigger picture and then share knowledge across all of the value chain.
Yeah, I think that's a good point, because some of the lower carbon solutions we know about, others we don't, and there is an element of unknown. And whether it's to do with new build or whether it's to do with how we refurbish aging assets, we need to be thinking about what is the art of the possible. So how do you collectively as a panel think, or how do you move ahead with the unknown unknowns? And I'm going to come to Masa first.
He's on mute.
Sorry. Yeah, it is a bit scary. You kind of share the risk, I think, of taking it forward. So you do as much as you can in the early stages to tackle the world of possibilities. You identify the risk profiles of what you're trying to do, so that you deploy at a level that as with reasonable skill and care as best as you can, and then you progressively keep testing and monitoring as well as you go forward. Because it comes back to the thing: if you keep waiting for all of the unknown unknowns, you don't know when they'll come up either. So we won't always be perfect, but we can do better. That's just the approach we have to take. But I think we have to share the risk in doing better to share the benefits as well and get to the kind of the common goal of decarbonizing.
Would anybody else like to come in on that one?
Yeah, one of the curious questions I've had as we've gone through it is on cross-sector information. So you may speak to somebody in highways and say, "Yeah, most of your experiences are in buildings." From a corrosion point of view, who cares? Yep, a 600 millimeter deep podium slab is not much different to a bridge deck. Might even have more steel in it. Yeah, so there does seem to be silo attitude sometimes when it comes to innovations crossing over market sectors, and where data exists on a particular reinforced concrete structure should be accepted, I believe, than any reinforced concrete sector. Otherwise, you'll never believe. Yeah, so everything becomes the first of a kind because it happens to be on a bridge in Scotland, or it's in a bridge in Indonesia, but it's in a bridge in England already, so it doesn't really matter. But it does to whoever. And an extreme example of that is I went to see a car park once in Burlington, Vermont, and I was asked by the client there, do you have it on any other car parks? Oh yeah, we've done a few car parks. No, I mean in Burlington. Well, they only had two. So if I hadn't put it on the other one, I wasn't going to get it on that one. Which is I say that anecdotally is a bit funny, but it does reflect our industry.
Some of the reality, yeah.
And our lack of belief in other experiences of other people in other circumstances.
Yeah, I think that's a good point, Graham. I second that.
Joe, do you want to come in? Oh, sorry, was that you, Ken?
Yeah, just reinforcing what Graham said is in the experience that we're noticing is the Ministry of Justice have had tier ones and SMEs and modular manufacturers collaborating, and as a result, there's been some innovation, and the benefits and the improvements they've been making. You don't think, say, prison construction could then transfer across the residential sector, but there is movement there, and that the lessons learned, the innovation on the MOJ prison program is transferring across into other sectors. So I mean that is just that principle of applying innovation across as many sectors as possible.
I agree, Ken. Joe, do you want to come in?
Yeah, thank you for flagging that. I mean, I think fundamentally, we really need supply chain to hold us to account as client organisations as well, and call out if it feels like we are being blinkered or not open to discussions around innovation and technology that's coming on stream. The other thing that that really struck me, and we've benefited from within the rail sector, is that global reach as well, because we're members of the International Union of Railways. That is basically a membership body globally for all either infrastructure or rail operators. And we've learned so much from other countries across the world in what they're doing. So I think it's about having your eyes open, thinking in everything, how can we look at this differently? I know it's the unknown unknowns. It's really tricky, but I think it's about mindset as well. It's about thinking about whether this could be applied in a different context. There are some really great examples of where that is happening. So yeah, thanks for flagging it.
James?
Yeah, I just wanted to add to that and say I think it's as I mentioned earlier, the question of say cost always comes up or health and safety elements. And I think until we do it, we don't know. Until we actually start tracking these things and we start measuring it and then we have these discussions, we never will know. So I think people need to make that jump and just start working with the process. It's obviously going to have teething problems as we go through, but we need to be developing it together. And when we do that, we'll then find the issues with different, say, processes or products. But then we can look how we iron that out, and then we can sort of build on that and find different solutions that might then solve that original problem.
But I think there's a, sorry, Joe, do you want to come in?
Well, I was just thinking, James, thank you, Kat. That's a really valid point. I think also sometimes, and I'm not talking on behalf of other sectors, but being kind of fairly open, we've got to kind of learn to fail fast and move on. If something's not working, let's not keep going and going and going at it. You know, accept that some things don't work and then look to something different. I've seen quite a few times in my role where you have almost kind of pet projects or, you know, individuals who are so wedded to something that they can't see that kind of bigger picture. So it is really important that, yes, we do try new things, but we also then, if they don't work, we stop, you know, working them and just move on to something new.
But looking on the other side of that, there is an element in terms of not always going back to what the traditional default is and then using that as your baseline. It's also about continued improvement, and those products and solutions which are successful and do need to be implemented at scale should then be your new baseline. And we've had a question similar to this in the chat, because otherwise we're never pushing ourselves forward and we're never understanding actually the problem's going to get harder and harder. It's not a case of, you know, I'll use the same figures I used 10 years ago, and yes, I can make, you know, huge savings. Actually, the savings will become less and less as they go forward because it'll be more tricky, and then those outside of the box thinking needs to be more prevalent. Graham, do you want to come in?
Yeah, just really to reinforce what you're saying there, Kat, and but with an example, you know, we've had our material under test out in the Netherlands and Berlin for wastewater applications for the last couple of years, and they were testing our material alongside two other low carbon concretes, and the reference concrete was GGBS mix of Portland, and that actually fared the worst in amongst the four test materials. So the interesting thing comes in, if you're going to repeat that test next time round, is that really your reference material anymore? Because you know it's not going to work. So your reference material next time should be one that you know is going to work. And if there's a new material comes along, your reference against that one that you know you're at least currently content with.
That's a useful point, Graham. James?
Yep, I agree with that. I think from, say, a framework perspective, it's looking at where those hotspots sit. And as you said, when we have, say, a new solution that we think, okay, right, this is something that across the board we can then implement, is working to make that business as usual, and then feeding that through into the baseline. And then that becomes our standard approach. But we need to make sure that that then is specified and that is accepted as that sort of baseline. And then from that, we can then build and go. It might be that on a framework of projects that say at the start, the pavement elements are the key hotspots, but because we've implemented all these changes into it, that's then lower. We don't want to then necessarily have that as our key hotspot anymore. And then we change that to something else. It might be, I don't know, for example, VRS, that we then go, right, these are where we definitely need to be pushing more in, and we know this is our key interest area now.
Yeah, because it allows for those sprints, doesn't it? Rather than trying to think you've got to boil the ocean to get every single thing reduced. But it also, I think, keeps the motivation and focus at a project level, and perhaps remove some of the blockers that we see, because there's too many things to go at. There's too many challenges and changes, and where does the risk lie? Where's the cost? But where you can be more specific, because you can make some of those clear and rapid gains is important. I just wanted to touch on a question around, obviously, when you're starting a new project, some of these things come up, but there is a shift in terms of there's less new builds being created. Actually, it's more about maintaining your existing asset base. And we all know in the UK, we've got a huge problem in terms of aging infrastructure assets. A lot of them were built after World War II. They're all sort of coming out of their lifespan in a very similar time. It's going to be hugely costed to replace that from a cost, carbon and broader environmental perspective. So there is a need to focus on asset health, and decarbonisation is a fundamental part of that. So a project becomes an intervention in extending the life of the asset. Think of it as a conveyor belt, and the assets are dropping off the end. You're trying to keep them at the front to give them a bit more time. When do you see, maybe Joe, coming to you first, in terms of when you're looking at your existing assets, are you looking at from a resilience perspective, or does carbon become one of the key requirements of that when you're deciding when is the right intervention?
Yeah, most definitely. It's something that has we've matured over recent years, whereas and we've had to, let's face it, we're all in financially constrained times now. So it's not just a case of build new. It is an our asset base. We're 200 years old now this year, the railway. So that tells you a lot about some of the age of some of our assets. So I think we have to think really carefully, working with our kind of technical heads, our asset engineers, on what's appropriate. We are taking a far more informed approach now when we're looking at investment in schemes and challenging ourselves. And as Stephen said at the beginning of the call, PAS 2080 accreditation, like being far more rigorous in our approach to infrastructure carbon and how we are actually looking at solutions. So yes is the answer. We are considering it. Are we quite where we need to be? I suspect not yet. Again, I talk about the journey, but we are most definitely improving in that area.
But some of that is having the information to understand actually what the carbon is already embedded in that, and also what bits are coming to the end of their life. It's sometimes not the whole asset, it's component parts. And then this is where, MMC, construct to deconstruct, really comes into its own, because you want to be able to swap things in and out as they're needed, as technology improves, rather than thinking I've got to invest in a asset once it fails, which perhaps has been the approach, 10, 20 years ago. So there is a different mindset that's needed.
Absolutely.
James?
Yeah, as you mentioned there, I think looking at the assets as a whole, rather, if you say have a length of VRS, can additional surveys be done to look at the conditions of those? So you don't necessarily have to replace the full length of it. You might have a portion of it, and then that's actively avoiding the emissions. You're not replacing everything all at once. I think the PAS 3090 that I was talking about briefly earlier, which is the sort of adaptation pathways for looking at sort of climate resilience, could be something important in the future. It's not something that's come out yet, but I think just a note for people to keep their eye out on that, because I think that will be something key, because a lot of the time it might be that the old infrastructure can't withstand the current climate demands that are they're put under if it comes to flooding or higher temperatures. And I think it's something that if we can look into resilient design and preempting where there may be problems, then we can reduce the amount of construction that's required in the future, and we can also look into implementing designs that are going to last longer. And if you're looking from a whole carbon life cycle perspective, we'll have lower carbon.
Joe?
Thanks, James. Yeah, it's adaptation pathways is a big focus for us. It will come as no surprise. Our infrastructure is constantly responding to recovering from weather events. So climate change is with us, and that's a big focus. In fact, we've been on that journey, I think, for a few years now, and we have a dedicated team looking at weather resilience and climate change adaptation. And we're also looking, interestingly, at things called the nature-based solutions. emissions. So actually less pouring of more and more concrete, and looking at, you know, our estate is vast. It's 56,000 hectares. It's you know, all across the three nations that we serve. So I think it's there are big opportunities there to make carbon reductions but still achieve resilience, but by using nature. So that's quite an interesting angle that we're focusing on as well.
Yeah, and that can also have a very positive effect in terms of carbon offsetting as well, in terms of not just even from carbon, but from a well-being, biodiversity perspective. You know, there are huge benefits that can add. But it's understanding that we have lots of infrastructure, and like network rail, like roads, they cross other things, and therefore, as climate change exacerbates, there's bigger impacts. Some of those problems then become problems for assets that were not designed in a way for flooding, were not designed in a way to manage those things because they were done 200 years ago. So we're shifting into a time whereby assets need to be looked at in multiple ways, not just for their sole purpose, because of the impact that's coming from a climate perspective. Yeah, challenging times, interesting times though. Graham?
Yeah, I would say they are definitely intertwined. The sustainability aspects as well as resilience, they have to be thought of together. You know, I think the famous quote is the greenest building slash structure is the one already built. So, you know, we've already got it here. We may as well look after it. Now, you start looking after something from day one. But actually, in day zero is quite interesting because what we're building into structures to be able to interact with the diminishing condition later on in its life without waiting for it to diminish before we actually start tackling it. So we're looking at methods of componentizing our materials, for example, to insert into new construction in order to control corrosion from day one. That's not an issue if you've got basalt, but it is an issue if you're going to adopt steel. But you know, I would just reiterate really that the fundamental need, and it is a design process, not too different than James was describing. You know, you look for what the problem is, the hotspot. You develop your design around what you want to achieve from a resilience and a sustainability point of view, and you build in those decision-making processes to the materials that you're adopting to achieve it. It's really not that much different. And as I tried to put in my presentation, there is also all the standards and processes already in place. What do you do to condition assess? What do you do to intervene? And when do you do that? What do you do it with? And how do you meet the end standards to produce a resilient service life? They're all there. They all exist. They just need to be adopted more fully. And I'll finish your point by saying that, you know, I've been doing this now for about 40 years. And I can walk you through decade by decade how little people were listening to how people were listening a little bit more, to how people were listening a bit more. And nowadays, people are really listening to the need to look after existing structures because people do realize you can't demolish everything and rebuild. It's too costly.
Yeah, and I think there's a realization that existing assets bring different things for different people and different purposes. So some of them are functional assets that we need from a day-to-day perspective, but others are also cultural and, you know, geographical importance. So it does sort of raise other challenges, but actually being able to manage our existing stock and manage the health of those is hugely important, and adaptation pathways is a key part of that, with carbon one of the key outcomes that needs to be achieved. I just want to ask one last main question of the panel in terms of what are the next big opportunities for cutting carbon further? Who would like to start with that one?
Graham, are you going or shall I?
Fire away, Joe. I'll do have something to say, but
yeah, I think, you know, what we've tried to do, the approach we've taken in Network Rail, looking just at the sheer array of materials that are used on our network, on our estate, we've tried to go for the as I said at the beginning, those kind of the bigger ticket items, because that's where you get the biggest bang for your buck and will get the most impact. But we're very much looking more at bringing together our kind of decarb and circular economy focus, and almost like just working our way down in terms of materials and the types of things that we use, clips and what have you, to then have a plan for how we tackle that. I think the other thing I'd like to just talk about is academia and the role that universities play in helping us, address some of these challenges, because we shouldn't underestimate the value that academia brings to all of our work. And so I think more of the same, and we will relentlessly go after in kind of order of priority, and impact those materials that we're using. And I think it's just really exciting to see the innovation that's now coming online, and how we can tap into that and shamelessly pinch good ideas from other client organizations as well.
Nobody needs to be on the back foot, and there's always an opportunity to learn from others. And I think academia has, and I agree, a huge role within future ways of working. But that doesn't always have to be about technical specific subjects. That is one huge part of that. But actually, there's also the people side of it, because supporting carbon management and working in a different way requires people change. It requires system and process change, digital ways of working. It's a whole host of different things. So it's just to expand on that, to say that, carbon management is a facilitator for lots of other things. But we shouldn't just say it's just about materials, because there's a whole host of other things. And when you look at PAS 2080, you look at it from a system, network and asset level. There's a huge amount of things that go in there, which actually opens up the opportunities for lots of different sectors. And I think that's also quite interesting. I know of a people-led net zero research term. I think it's like 4 years that started this year. So that's another one. So it's still quite topical on a lot of different things. But just going back to the question in terms of next big things for carbon, anybody else who wants to come in on that?
I think James was before me. So.
Okay, I'll join the queue.
To be fair, I was going to add on to what Joe was saying before, and what Graham was mentioning previously as well, which is about how in the past people kind of were slightly touching on it, and now it's a big thing and people are getting more involved. And I think making sure we do have those roles and responsibilities across all of the value chain is one of the first parts of PAS 2080, is making sure we have the right people in the right positions that are driving the change and pushing for carbon reduction, and upskilling teams as well. So from the design point of view, I think one of our biggest opportunities is making sure that our design teams know exactly the processes that we need to be following, are confident in their carbon literature, and they can go away and talk to the clients, talk to the suppliers and contractors, and be pushing for change. And similarly, from the other side, from the contractor and supplier sides, having those people that are in place that are confident to go and challenge the designer and say, actually, can we change this part of the design? And I think once we have that process in place, the innovation will come out of it, because people will be having those conversations.
Absolutely. Graham?
Yeah, I would say that and the question in particular, we're not going to know yet. I think it's almost undoubted that there will be research ongoing in universities right now that are early days. I know the development of our product dates back 25 years. We didn't see it for 15 years, and then we did it ourselves for 15 years. So it's there is something out there, I have no doubt, and I personally don't know what it is. But what I would say is that all the steps and everything I've heard today from all the other speakers, it's so heartening, because you can see the direction is right. You can see the processes developing. You can see the thinking fleshing out into something that is very, very tangible. And I think what we have to see now is the benefits of that. Get the implementation more widespread on more structures. Get the belief rolling. But
That's great. Thanks, Graham. Musa?
I think there are a couple of things that I look at as key areas that will help us to improve. One is data. Are we getting to more objective positions with how we quantify carbon? I think we are slowly getting there, but one of the big questions around how good carbon numbers are is still who's counting, and we need to get away from that. So we need better data because that gives us a baseline as well. There's better a measure of improvement, and we can measure against that more accurately and more consistently. Process is key, and that's why I'm working hard with the National Highways and Ramble team at the moment to actually create the pathways that are clearer, so that we accelerate how easy, or we make it easier for projects to adopt things. That brings benefit faster. And the third piece is, I was talking to a researcher from the Net Zero Bridges group a couple of weeks ago on some of the things that are currently harder to estimate and measure. So the carbon impact of a traffic management scheme, for example. There's some significant associated sources of embodied carbon that come with these extra things. If we can start to develop more methodology around some of those things, we'll get better and better upfront when we're deciding the right approach and intervention. So if it's for a rehabilitation scheme, I might be able to deploy a low carbon material, but if it takes 20 weeks versus something that might take 2 weeks, and I can measure the impact based on that 20 weeks for super low carbon, or 2 weeks for something that is maybe a bit more intensive, but it alleviates the broader impact, I can make a much more holistic judgment up front to actually get best value. So those are a couple of avenues that I see coming together.
Super. Ken, any last remarks before we move on?
Been a very, very interesting morning. There's been some interesting stuff. What I wrote down actually was, perhaps we hope we need CIRIA and BOS to organise as an innovation forum to bring together the people who are interested in actually hearing about other ideas, because there have been quite a few today. I mean, one of the things that we're hearing about across the building sector is retrofit, and perhaps then that needs to be looked at in a lot more detail for the infrastructure sector. But I think it's been an excellent a webinar this morning, Kat.
Yes, absolutely. So just conscious of time now. So thank you very much to our panel. Really do appreciate all of your presentations and inputs. So Stephen, James, Joe, Graham, Musa and Ken. I think it's been a really informative webinar today, and I hope our listeners have really been able to tap into the knowledge that you've been able to present today. So thank you for that. We'll circulate a link of the speakers' presentations, provided where we have their consent. We'll endeavour to respond to any questions that are not covered today. And if you have any additional questions for our speakers, please contact the CIRIA team. So anything that's in the Q&A will be responded to if we've not covered it off already. But I think across the board, we've had the client view, we've had the designer view, we've had the contractor view, and we've had the suppliers view. So I like these webinars because I get excited in terms of you're always learning something new. And I think within carbon management, it's about the sum of the parts to be able to shift industry forward. And I think what we've heard today is that no matter which direction or position that you're in, everybody can have an impact, and everybody is allowed to and be empowered to take their stance in terms of decarbonising our way of working, our assets, and the work that we do on a day-to-day basis. So thank you for that and your input. So just in terms of our feedback poll, we'd be keen to hear about your webinar experience, and we'd be grateful if you could complete the short poll, which will be on the screen now, so you should be able to see that. Well, also, if you want to receive a CPD for this webinar, you will need to complete the poll. Upcoming events, we have obviously a climate change risk management for land projects new CIRIA guidance webinar on the 18th of March, SUDS in practice on the 26th, CIRIA annual debate, AI in construction, embrace or avoid in 22nd of April, SUDS implementation, thriving biodiversity on the 29th of April, 11th of June, BOPAS Forum and Hadley Group Tour, and then on the 16th of July, advancing good practice in PFAS risk management in UK projects. Other things that are coming up, we have the Net Zero Carbon Offset Champions. So obviously this is an ongoing project in terms of modern methods of construction, which I mentioned at the beginning of our webinar. The project will showcase 8 to 10 leading case studies. So there is always an aspect of technical and financial support on this one. And then the last one is Chelsea Flower Show 2027. So Build Offsite is proud to support the concept of SUDS Garden in the 2027 Chelsea Flower Show, collaborating with Reflow, Landscape Architects, CIRIA and Future Water. The garden is about more than aesthetics. It's about showcasing innovation, resilience and sustainability in a way the public can see, touch and celebrate. So please do look out for that, whether you're a visitor or you're watching it on the BBC coverage. This is the platform to show the world what offsite construction, extend it into landscaping can do. So please register interest on the QR codes. But to everybody, thank you to our listeners and thank you to our presenters and panelists. Really do appreciate your input today. Thank you.
Thanks, Kat.
Cheers all.